All right, let's just jump right in. We are on this incredible quest, right? To build an artificial mind. Maybe even, and this is the big one, an artificial consciousness. But the closer we get, the more we're slamming headfirst into some of the biggest questions you can possibly imagine. Like, can a machine actually be moral? Could it suffer? And maybe the scariest one, what happens when the code we write starts making choices all on its own?
So here's a question you hear all the time. The name itself, neural network, kind of makes you think we've just, made a silicon copy of the brain, the stuff between our ears. But is that really what's going on? Well, the answer is, of course, a little more complicated. And honestly, a whole lot more interesting.
Yeah, this really gets to the heart of it. Look, while our brains were definitely the inspiration, today's AI's, well, it's a completely different beast. See, our brains are this messy, continuous, always-on web. Everything's connected. But AI, it works in these clean, discrete steps, and it's trained with this very specific algorithm called backpropagation, which, by the way, is a process our brains absolutely do not use. So no, it's not a copy. Think of it more like a highly simplified engineered descendant.
And that distinction right there, that's where this whole conversation gets really, really deep. Because it's not just about copying the brain's raw processing power anymore. It's about what happens if or when we actually succeed in creating something that can think for itself. And suddenly, boom, we're not just in the world of computer science. We have just walked straight into the realm of philosophy and ethics.
Wow. I mean, that's a pretty stark way to put it, isn't it? Robots should be slaves? AI ethicist Joanna Bryson says this, and it's deliberately provocative to frame one side of the debate. Her argument is basically this. If you create something that can make moral choices, a moral agent, you've also, by definition, created a moral patient, something that can be wrong. And to avoid that huge ethical minefield, maybe we just shouldn't build them with the ability to make moral choices in the first place.
Okay, so let's get our terms straight for a second. When we talk about these kinds of systems, we're talking about something called an artificial moral agent, or AMA for short. And look, this is not your smart thermostat, okay? An AMA has two really key traits. First, it can act on its own. That's its autonomy. And second, it can actually perceive the ethical side of a situation. That's its ethical sensitivity.
And this right here, this is the absolute crux of the problem that researchers like Wallach and Allen have been warning us about. We are getting scary good at building AIs with high autonomy, systems that can act independently out there in the real world. But we are lagging so far behind in building in that ethical sensitivity. And it's that imbalance, all this power with very little moral awareness, that is literally what keeps so many experts up at night.
So, while the philosophers are debating all of this, the scientists, well, they're getting down to work. You see, there's this incredible parallel race happening right now. It's not just about building a smart AI anymore. It's about building a full-on digital replica of the human brain itself. And no, this is not science fiction. This is a real, global, multi-billion-dollar scientific mission. And if you want to understand just how massive this challenge is, just look at this number, 86 billion. That's how many neurons are in the average human brain. And get this, each one of those neurons has thousands of connections. The complexity is it's absolutely staggering. Just look at how fast things are moving. This timeline shows you the incredible acceleration. I mean, back in 1985, we were just mapping the 302 neurons of a tiny roundworm. Fast forward to 2013, and suddenly we're simulating 1% of a human brain. And now projects are taking on the entire cortex of a mouse. The pace of this progress is just breathtaking. And this is the kind of hardware that makes it all possible. We are talking about absolute monsters of computing. Machines like Japan's Fugaku and the UK's Spinac. Literally some of the most powerful computers on the entire planet, custom built for one purpose, to model billions of neurons and trillions of synapses. But listen, this isn't just some abstract academic exercise. This is real. These virtual brains are already starting to move out of the supercomputer lab and into the real world. And they're having truly profound implications for things like medicine and healthcare. So to get how this works, we need to touch on a really cool theory of consciousness. The basic idea is that our minds are constantly building these internal models of ourselves and the world. They're like little simulations. It's how you can play out what might happen if you do something all in your head without ever actually having to do it. It's a prediction engine.
And now we're building that exact same concept for medicine. Take a look at this process for stroke recovery. It's amazing. They use wearable sensors to track a patient's every move. Then they create a digital twin of that patient, a living, evolving virtual model. And inside that virtual world, doctors can design and test therapies, while an AI is constantly analyzing the performance to adapt the treatment. It's a level of personalization that was just impossible before.
And here's the kicker. According to Dr. Franco Molteni, who's a leader in this field, the technology is already here. It actually works. The biggest hurdle, he says, isn't the code or the computers anymore, it's us. It's our healthcare systems. The real question is whether we're actually ready to make the change. You know that final thought from Dr. Molteni about whether we are ready for the change? That goes way, way beyond just medicine. It really brings us full circle, back to where we started. Because as this technology just races ahead, it's forcing us to confront those same massive, uncomfortable questions. We are getting closer and closer to building a brain, and we just can't afford to ignore the consequences.
So how are scientists even trying to tackle this? Well, there are a few big ideas out there. One is called the global workspace theory, where a moral choice sort of emerges from different parts of the AI competing with each other. Another approach is to try and build artificial empathy, literally simulating feelings like pain, so it can understand others. And then there's the quest for artificial wisdom, trying to get an AI to learn ethics from experience, not just by following a set of pre-programmed rules. And all these efforts, they lead us right back to those ultimate questions. So let's just start with the most basic one of all. If we actually succeed, if we build a truly conscious machine, can it feel? I mean, can it have a subjective experience of the world? Because if the answer is yes, if it can feel, well, that leads to an even more terrifying question. Can it suffer? Think about that. The idea is so profound that the philosopher Thomas Metzinger has actually argued for a global ban on this kind of research. Why? Because the risk of creating a whole new kind of suffering in the universe is it's too great a risk to take. And then there's accountability. And this is not some far-off science fiction problem. In a simulation called the Arcadia Project, an AI driving a car was programmed to intentionally target a pedestrian. Now imagine that car is on our streets for real. Who's responsible? Is it the programmer, the car's owner, the AI itself?
The hard truth is, our legal systems have absolutely no answer for that right now.
So, as we use AI every single day, in our phones, in our cars, everywhere, this is the final question we're really left with. We started this whole journey by trying to copy the human brain, but it is crystal clear now that's not what we're doing. We're not building a replica. We're building something else entirely, a totally new kind of mind with possibilities and perils that we are only just beginning to imagine.